All right, guys, so we went over some of this yesterday. We got through direct inverse. We got through these. We got, because we finished, yeah, we finished up 13, 14, and we were on 15. So if we have time after we get through all this to go back and look at those other ones, we can. Otherwise, it is posted up. I did post that up there for y'all. So when we look at any of these here, especially 15 and all these, simplifying, multiplication, and division, addition, subtraction, I would try to factor it out as much as we can. Now, with addition and subtraction, we won't factor the numerator as much, or really at all. We'll factor the denominators to get them to be the same.
I'm sorry to interrupt. I saw a floor lamp back in this closet. Is
Yeah.
that yours?
Yes.
Can Mrs. Kendall borrow it?
Yes. So, when we look at this one here with this multiplication, we want to factor the numerators and denominators, and then we can multiply through to simplify. So we look at x squared minus 4x. Well, since we only have two terms and there's not a constant, most likely we're just going to be taking out a greatest common factor. So we take out a greatest common factor between these two terms, which would be just x. Because I could factor an x out of both of them. When I factor an x out of x squared, we're left with x. And when I factor an x out of 4x, I'm just left with 4. Well, the x minus 1 doesn't factor because there's not a greatest common factor, and there's only two terms. There's nothing else we can do with it. Is there a bulb still in that?
Yeah, there is.
Okay. Now, 2x doesn't factor either. So that just leaves us with our x squared plus 3x minus 4. And we're going to factor that there. Since the 4 is negative, our signs are going to be opposite. We're going to have x and x. So we'll want 1 and 4. Yeah, so we're wanting 4, and we're wanting to get it to middle term to be 3. Now, since the middle term is positive, and there's no term number with x, we're just going to want the bigger number to be positive. And that's it factored. Right, the x minus 1 on top and bottom would cancel. And the reason we can do this is because they're being multiplied together. Since everything's being multiplied, we can do the simplification. And we also have the x and the x. And what that leaves us on top is x minus 4 times 4, and it's all over 2. We couldn't multiply them together, but there's nothing that will simplify it down any further than this here. It is. It is a difference of perfect squares, so we can multiply them together to get x squared minus 16. So there's nothing wrong with that, but it's not making it any simpler than what we have here. Yeah, no, you're good. So any questions on this here? Now, we do have a restriction of 0 and 1, but unless it says to list the restrictions, you don't have to do it. Actually, with the break, I'm not going to be a stickler about restrictions on most of these here. Okay, I'm going to pull that out. Okay. Let's look at another one here. Let's look at 16. So when we look at 16, so we can just go start from the top and factor this here. X squared plus 3x minus 4. Well, since the 4 is negative, our signs are opposite. We have x and x. Well, 4 and 1. We just factored that a minute ago. Then on the bottom, we have x squared plus 4x plus 4. It's going to be positive and positive because since 4, our third term is positive, the signs are the same and they match the sign of the middle term. We'd have x and x, so those are the only factors of x squared. And then we'd want, what? Almost. 2 and 2. Because with 4 and 1, since the signs are the same, they would add together. So 4 and 1 would give us 5. Because when we multiply through, 4 times x would be 4x, x times 1 would be x, so 5x. So it's a good place to start, but it ends up not working out too well here. Now 2x squared plus 4x, this is a little bit easier, because they do have a greatest common factor of 2x. When we factor 2x out of 2x squared, we're left with x. Our 4 divided by 2 would give us 2, and the x factors out completely. Now we have x squared minus 4x plus 3. Both negative, x and x. And 1 and 3. Since it's positive, third term is positive, the signs are the same. Matched middle term, which is negative. All right, now we can just start canceling things out. Right, x minus 1, x plus. So we just take away one of them. So really what we're doing, and I haven't written this out too much, is that, so I'm going to move everything over here because, again, multiplication, we can multiply in any order on top and bottom, yes? So what I'm going to do is I'm going to move this over. We're going to have our x minus 1 and x plus 2 over here. Well, it simplifies out with the x plus 1, x plus 2 on them, yes? And I moved it over there. I'm going to move everything else over here, 2x times x plus 4. And you don't have to write this out. But this is essentially why multiplication works and addition and subtraction doesn't. Because when we look at this here, is this any different than the one above? Well, no, they're just being multiplied together, yes? And anything divided by itself is what? 1, yes? So this whole term over here becomes what? That's why we can simplify with this multiplication and division, because I pretty much move everything over that's the same. Simplifies to 1, simplifies to 1, simplifies to 1. I have what's left. Now, if we'd had another x plus 2 on top, then they would cancel. But since we only have 1 on top, it will only cancel out with 1 on bottom. And this here would be our answer, because this here is just 1. Questions on this here? We good with this here? Awesome. All right, let's look at 17. On time. Does anybody need to see 17? Because if we feel comfortable with this here, we can come back to 17 later. I want to make sure we get through everything first. So let's look at some division and then look at some solving. And if we have time, we'll come back to those. Any of the ones we missed, we can come back to it in a bit. So when we look at this here, again, with division, the first thing I would do before I start rewriting things is change it from division to multiplication. I would change it from division to multiplication. Now again, like the first multiplication that we did yesterday with two fractions that didn't have any addition or subtraction in them, we have two different ways we can go about it. We can either multiply them together and then simplify, or just simplify here. Either way is just fine. Now if we just multiply them together, 8 times 32 is going to be 256. Then we do x to the 4th times x to the 3rd, which would be x to the 7th. And then we just have y. We just multiplied those numerator terms together. And the denominator, we have y to the 8th times y to the 7th, which would be y to the 15th. And the only thing we really have in common on top and bottom is that 1y. So we have 1y on top and 15 on bottom. And whenever we're dividing like bases, we subtract the exponents. So 15 minus 1 is it bigger on top or bottom? So it'd stay on bottom. As this cancels out, this becomes 14. And that's it. Because we could have canceled out some terms and said, okay, this cancels out and this becomes 7. Well, we get to the same thing. So we can do it either way. Yes. Top one is an X. Yes, sir.
So why would you use
We would. Because once we turned it to multiplication, we can treat it like the ones before. But we have to turn it to multiplication first, because we can't just start here and do that. We have to switch it first. I think that answers your question. Maybe if we look at another one, it'll make sense here. So when we look at 19, again, before we do anything, we're going to change it from division to multiplication. So our first fraction stays the same. Our second fraction, we change it to multiplication and flip it. So that's going to be a good place to start so that we know that we're dealing with multiplication and we don't forget to do that later. Now that we have that done, we can go on and factor these terms, factor these sets of parentheses. So x squared minus 3x minus 40. So we, right? Since 40 is negative, our signs are going to be opposite. We'll have x and x. Now the factors of 40, what we end up getting is 8 and 5 are going to be our factors, where 5 is going to be positive and 8 is going to be negative, because negative 8 plus 5 would give us our negative 3. Now we can look at the denominator, and again, because the 20 is negative, our signs are going to be opposite. We're going to have x and x. And if we look at the factors of 20, that give us 8. Well, that's going to be 10 and 2. Because 10 minus 2 would give us a positive 8. Okay. That'll bring us up here to the numerator. Since the 20 is positive and the middle term is positive, they're both going to be positive. Factors of x are going to be x and x. Now the factors of 20 that would give us 12 are going to be, well, almost 2 and 10. 2 and 10, yes. 2 and 10. And again, we're going to have, both are going to be positive, since 40 is positive, middle term is positive. And the only factors of x squared are x and x. And factors of 40 that we're going to use are, well, 5 and 8. Huh? Yes.
Oh,
Mhm.
here's well,
Yeah, I saw that too. And it's,
I was let's say what x squared plus 13 plus
Oh wait, no.
Oh, okay, I see.
yeah, we flipped it. You're good? Yeah, the 13, the bottom part of that 3 on top, kind of got stuck into the division bar. You're good? And again, on the test, if you have questions about how something looks, ask. I will always answer. Okay. Now we can simplify on top and bottom. X plus 5, x plus 5, x plus 10, x plus... Right, and what's left is what we have an x minus 8 and an x plus 2 over an x plus 8 times an x minus 2. And this would be our answer. Now, we did cover some where we were able to pull a negative out and get them to be the same. But for that to work, both signs had to be different. So if that would work for, say, this one here, where we could pull a negative out, the x had to be negative. Because I'd have to have negative x plus 8 to be able to pull it out to get it to be x minus 8. Both signs had to be different. So if only one sign is different in any of these, there's nothing we can do to make them be the same. But that's it we have to do here. Questions on this here? Okay. So we're going to look at these here, these addition and subtraction problems. Number 21, a problem of this complexity will not show up on the test. You're not going to have 3, and especially you're not going to have 3 different, actually that's not that bad, but you're not going to have more than 2 terms or more than 2 different things that you have to make them be the same. Now if we look at number 20, well the denominators are already the same, yes? So we can go on and subtract the numerators. Yes. So we'll subtract the numerators, the 4x squared minus 1, and we get 4x squared minus 1 over 2x minus 1. Well, we can factor 4x squared minus 1, because 4x squared is a perfect square, yes? 1's always a perfect square. So we know that the signs are going to be opposite, and well, 1 and 1. So what would the 4x become? 2x and 2x. Well, hey, 2x minus 1 and 2x minus 1 would, leaving us with, and that's it. That's all we have to do for this here. So we added them together because the denominators were the same. We noticed that it factored, so we factored and simplified. So any questions on this here? Okay. Actually, after looking at this here, this one's not as difficult as it looks, because I thought this was going to be more complex than it was, because of 3 terms. But the denominators on all of these are what? The same. So this one actually is a little bit easier than what I thought it was going to be, because we can add the terms together. Well, yes, because 6x plus 6x is 12, and negative 1 plus 5 is 4. So this one here wasn't as bad. I'm thinking of another one coming up. Now, when I look at this here, this is going to factor. Since 4 is positive and the middle term is positive, we have plus and plus. I would use 3x and 3x. 2 and 2. Because 3x times 2 is 6x. 2 times 3x is 6x, and 6x and 6x makes 12x. So it does work out, and well, these cancel, leaving us with 3x plus 2. So the big thing with addition and subtraction is making the denominators be the same. Once we get the denominators the same, then we add or subtract. And if there are any quadratics in the denominator, we're not worried about the numerator, but the denominator, We need to factor them so that we can get them to be the same. Now, I'm not too worried about x squared minus 5. Yeah, no, this is the one we're not doing. So when we factor this here, x squared plus 5x minus 14, well, since we have minus 14, the signs are going to be opposite. The factors of x squared are x and x. Now, the factors of 14 that we're going to use, 2 and 7. And the 7 would be positive because the middle term is positive. And the main reason that works is because we just have x and x. We don't have a number in front of x. Then we need to be a little bit more careful with that. Now, the other one doesn't factor at all, because there's no greatest common factors. The denominator is as simplified as it gets. Okay, now we need to make the denominators be the same. So I'm going to look at the one on the right first. What is x plus 7 missing that this one, x plus 7 times x minus 2 has? So the one on the right is missing an x minus 2 on bottom. Okay, so we're going to multiply top and bottom by x minus 2. Now, is there anything the one on the left is missing that the one on the right has? No, it already has the x plus 7, yes? So they're already the same. I just had to change the one on the right to make the denominators be the same. Okay. So that means the one on the left we don't have to do anything to. Now the one on the left we're going to have to multiply by x minus 2. Go all the way through. X times x would give us x times negative 2 would be negative plus 3x minus 6. Okay. I'm going to be a little bit lazy, and I'm going to go on and write them all on the same fraction, in the same fraction. But we need to use parentheses if we're going to do this, because again, that negative has to travel through all the terms of the second one, because we're subtracting it. So we'll put parentheses around it just so we remember. We have x squared. We're doing another step. Because what's negative 2x plus 3x? Plus x, yes? Are we comfortable with this step? Yes, okay. Minus 6, okay. Yes, and that's essentially what we're doing. Yes, we're timesing it by a negative. Yes. X squared minus x squared is 0. These are gone. Well, negative x is by itself. And negative 5 plus 6 is? And that's it. Because it's dealing with making the denominators be the same, and that gets a little bit challenging. Any other questions on this here? Okay. Least common multiple, least common denominator, it just depends on what we're using this for. So we're wanting to see what is the smallest terms, bigger than these, but to make them both be the same. We're trying to make them be the same and figure out what that is. So if I look at 26, well, 2x squared is as simplified as it gets. Yes, there's no way I can factor it. 4x plus 12, well, we can make it a little bit simpler because there is a greatest common factor between 4x and 12, which is 4. And if I factor it out, I'm left with 4 times x plus 3. We can factor that out. We want to try to simplify these down a little bit so that we can see if there's anything in common. Now, to get the least common multiple, well, one of the things I do know for sure is that I'm going to need an x plus 3. For them to both be the same, they're both going to need an x plus 3. What else do we know they'll both need? Well, an x squared, yes, because 2x squared has an x squared, so to get them to be the same, they're going to both need an x squared. Now we're left with the 4 and the 2, yes? What's the smallest number that I can make 2 and 4 be the same? So we're going up. We're normally going up. There's a number smaller than 8. Because, again, when we're looking for these numbers, we're going up. We have to go up. We have to increase. So we're looking at 2 and 4. We can look at the multiples. Well, 2, 4, okay, 4. Because we're looking for the first number going up on both of them that they match up and are the same. So the least common multiple for this here is 4x squared times x plus 3. Now we can look at 27 next. X squared plus 3x minus 40 and x minus 8. So if we factor this here, x squared plus 3x minus 40, because it is factorable, we would have plus and minus and x and x. I know plus and minus because the third term is negative. And now we need to look at the factors of 40. Well, this would be 5 and 8 would be the factors that we wanted. Now, x minus 8 is not factorable because that is as simplified as it gets. Okay? Now, with these polynomials, these sets of parentheses, it's a little bit easier to work with. Because if I want them to be the same, well, I know I'm going to need an x minus 5 and x plus 8, because both of them are going to have that, yes? Is there anything else I might need? Yep, x minus 8. For these to be the same, we just needed all 3. Because when we get sets of parentheses, it's just taking each one, and if one of them has multiples, okay, I'm going to need it more than once. Yep. Let's look at 28. X squared minus 2x minus 63. We'll have x and x plus and minus, because since 63 is negative, the signs are opposite. Now, the factors of 63 that we're going to use are going to be 7 and 9. The 9 is going to be negative, and the 7 would be positive. Okay. So I know I'm going to need an x minus 9 and x plus 7 for the least common multiple, because I'm just pulling them from the first one. Okay, and our other one was x plus 7. We already have it, don't we? Now, if the other one had been x plus 7 times x plus 7 and it appeared twice, we would need it to be twice in the least common multiple. But because it only showed up once in either one, we only need it once. With the numbers like the first one with 2 and 4, it might be, you could go on and write the multiples of 2 and the multiples of 4, so 2, 4, 6, 8, 10, 12, going out, and do the same thing with 4, 4, 8, 12, 16, and see when's the first number that they both are the same. Well, they're both at 4, okay, that's the one we're going to use. So with the numbers, you can go on and write their multiples out. Well, with 30, well, it's just going to be x plus 9, 2x minus 1, and 3. Because that's least common, really least common denominator. And I'm not going to worry too much about 29. We can come back to it later. Bless you. You know what? Let's go back and look at that one multiplication I skipped. Number 17. We'll finish up the review sheet tomorrow because I want to go through more than just one or two of these equation ones, and I don't want to go try to get more than two. It'll be a challenge to get a bunch of them done in 13 minutes. With multiplication or division, if we don't have a fraction in one of them, it just means the denominator is going to be 1. But when we're dividing, we flip it and it goes into the numerator. So the denominator of this x squared plus 2x minus 8 is 1. And that's only the real trick to it, is just making it 1. And then it goes the same as all the others. Now we can go on and factor this here, x squared minus x minus 12. Since we have the third term is negative, our signs are opposite. Factors of x squared are going to be x and x. And the factors of 12 would be 3 and 4. Yes, 3 would be positive, the 4 would be negative. How about the x squared minus 16? Yes, but we wouldn't put them together. It'd be x minus 4 and x plus 4. I think you had it up here, it just didn't make it. And the last one we have is x squared plus 2x minus 8. We'll have plus and minus because the 8 is negative. X and x for x squared. And factors of 8 that we want to use. 2 and 4? Do you agree with that? 2 and positive 4. And what's going to cancel? Yes. The x minus 4 and x plus 4. Which will leave us with x plus 3 times x minus 2 in the numerator. And, well, the only thing left in the denominator is 1. So we don't have to write it that way. We don't have to write it over 1. We can just write it as x plus 3 times x minus 2. That's all we have to write this as.